Hey guys, welcome to the lecture on the midsegment theorem. We're going to go ahead and get started. Again, this lesson is just kind of an aid or a supplementary resource for you to study your midsegment theorem. So before we even get started, I'm going to cover the theorem on alternate interior angle converse. So this theorem states, here it is, if two lines are cut by a transversal, so the alternate interior angles are congruent, then the lines are parallel. So what this actually means is that if my alternate interior angles are congruent, so here we have one, here we have the other, if these two are the same, then line J and K have to be parallel. They have to. So again, if my alternate interior angles are congruent, then my lines are parallel. That's all this theorem is saying. A midsegment. We define a midsegment of a triangle as a segment that connects the midpoints of two sides of a triangle. So here we have a picture of it, but moreover, if I have any kind of triangle, here's a triangle, and I know the midsegment, I know the midpoint of this segment here, so let's label it A, B, and C. I know the midsegment of B, let's call it right there, and I know the midsegment of BC. That would be somewhere here. If I connect those two lines to create a segment of its own, then this segment is midways of this triangle, or is the midsegment of this triangle. So essentially what a midsegment of a triangle is just a segment midways between the triangle. That's all. So another example would be, again, A, B, C. So let's say I know the midsegment of BC is here. I know the midsegment, I know the midsegment of AC is right here. If I were to connect these together, I create a midsegment. So again, this segment is halfway between this triangle. Our theorem, we're going to go over the theorem first, and then some applications, then we're going to prove it. So for this theorem, it just states that the segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long as that side. So what this is saying, here's my triangle, is that if DE is my midsegment, then it has to be halfway between my triangle, it has to be parallel to my base, and it is exactly half the measurement of my full base. So again, if I have another example, let's draw another triangle. Let's say I know that this and this would be my midsegments or my midpoints. If I connect them, I create a midsegment. This midsegment has to be parallel to my base, and the measure of it is half the size of my entire base. So let's look at an application of this midsegment theorem. So here we have an example. It says triangles are used to strengthen the roof trusses, or for strength in roof trusses. In the diagram, UV and VW are midsegments. So if we follow those, UV is right here. That's the midsegment, and it's parallel to RT, that's its base. VW is this midsegment here, and that is parallel to SR. So it says to find UV and S and RS. So let's go ahead and write UV, or segment UV. Let's locate it. It's right here. So by the midsegment theorem, UV has to be half the distance, or half the measurement of my entire base. If my base is 90 inches, then half of 90 inches is just 45 inches. Likewise, for RS is our entire base. So if I were to draw a triangle to kind of mimic that one, this would be RS. So then my midsegment would be, in this case, VW. This is V. This would be W. And we know that its measurement is 57 inches. So if this is halfway point, or this is the mid segment, then this is half of what SR has to be. Or in this case, this is half of what RS has to be. So to figure out what RS is, we would just have to double. So if this is half ways or half the size, we would double its length. So 57, and we would double that, we'd get 114 inches. So that's a good application of the actual theorem itself. Here we have a little bit of I kind of divided into three different parts. This was for the classroom, but we can also knock it out as an extra example. We're still using our same triangle truss, our roof truss over here. For the first one, it says name the third mid-segment. So we know UV is a mid-segment of, or parallel to RT, and also the mid-segment. The other one is VW is the mid-segment. It's also parallel to RS. So the only one we don't have anything parallel to is ST. So this mid-segment would actually be UW. So segment UW would be my third mid-segment. For the yellow, it says to find ST. Well, ST, this is the entire length. If I know that this mid-segment is 81 inches by the information given here, then if I were to double that, I get 162. Done. SV is half the distance of the base. Well, half the distance of the base is also my mid-segment. So if they're both halves, they should both be equal. So this would be 81 inches. And we're done. So finally we get to the actual proof. This proof is kind of lengthy, so I'll try to be as clear as possible. We're going to try to prove this bad boy in 12 steps using a 2-column proof in 12 steps. So let me begin by listing what it is that we have, or what is given to us as part of this proof. We know that DE is the mid-segment, and we have to show that DE is parallel to BC. Well, if it's the mid-segment, it has to, D has to be the midpoint of A and B, which means we create some congruencies. We create that AD is congruent to BD. That's also by given. We also know that AE is congruent to CE. That's also by congruency. So that's given to us. That's given information. So now what we want to do is we want to go ahead and construct a point outside of this. So I'm going to construct this point here. I'm going to call that F. I constructed F such that it is exactly the same distance as DE. So this distance here should be the same as EF. So what I can state then as my statement for 2, here's 2. I'm going to state that DE, or segment DE, is congruent to segment FE, or EF. That is by construction. Here it is. So that's by construction. So if that's the case, I'm going to go ahead and connect F and C. You can also write that in, and that it would be by construction, or just kind of draw it in. Good. So if that's the case, we have these angles here. These angles are known as vertical angles. So they're vertical angles. So I can make another statement now. I can say, cool. For 3, I can say angle DEA is congruent to angle, let me flip this around, to angle FEC. So this angle here, congruent to this angle here. These two angles are congruent by the definition of vertical angles. Okay, vertical angles. Cool. So if that's the case, we have enough information to see that this triangle is congruent to this triangle. If that's true, we can go ahead and show it as our step 4. It's triangle, we're going to go AED. Triangle AED is congruent to triangle CEF. And the reason is by side angle side. Side angle side theorem. So if these two triangles are congruent, then corresponding angles are congruent. Then by triangle congruency, then corresponding parts of corresponding angles are congruent. So that's one of the theorems. So I'm going to go ahead and show, or I know that this has to be congruent to this side. So that's true. All three of these sides are congruent. But moreover, I care about this angle here is congruent to this angle here by corresponding parts of corresponding triangles. So I'm going to go ahead and write that in. So I'm going to say, cool, angle ADE is congruent, angle ADE is congruent to CFE, to angle CFE. That is by triangle congruency or corresponding parts of corresponding triangles. Triangle congruency. By definition. All right, so if that's the case, then if this angle and this angle are congruent, or angle D at this moment and angle F are congruent, then those would be alternate interior angles. Since they're alternate interior angles, by the theorem we covered in the beginning of this lesson, we know that BD, or better yet BA, is parallel to FC. So anytime two alternate interior angles are congruent, their lines have to be parallel. That is by the converse of alternate interior angles. So I'm going to go ahead and label that. I'll label that with the blue. That means that this now becomes parallel to this. So those two are now parallel. So I'm going to go ahead and write that as a statement. So for 6, I know that segment AB is completely parallel to segment FC. And that's by alternate interior angle converse theorem. So there we go. We got our first pair of parallel lines. Now we've pretty much showed everything congruent that we can at this point. So what we're going to do now is we're going to go ahead and construct another line. I'm going to go ahead and construct DC. That's pretty off, so I'm going to try that again. Whoa, we just lost. Hold on. Alright guys, sorry about that. There's a little glitch on my computer. It kind of shut down. But I was able to kind of reconstruct it and pick up where we left off. Alright, so I was trying to construct this line segment DC. So I'm going to go ahead and try that again. I guess it's a little better. So I'm going to go ahead and write that as one of my steps. I'm going to show that DC, or draw segment DC. That is by construction. So we're allowed to pretty much construct anything we want as long as we give it a reason for it. So when I drew this segment, we created two triangles. We have triangle BDC and triangle FCD. The top one, long top one here, and the long bottom one down here. I'm going to want to show congruency for these triangles. So far we know that this segment is congruent to this segment, so they have something in common. The other one that we know immediately is that DC is congruent to DC, and that's by one of our favorite properties, the reflexive. So I'm going to go ahead and write that down. Segment DC is congruent to segment DC. This is by reflexive property. Reflexive property. If that's the case, I'm going to go ahead and draw that in. So this is going to be our fourth congruency. 2, 3, 4. Okay. So now they share this wall and this, or this side and this side, and then they share the center side. So the next thing we want to show is if we can show this angle and this angle is congruent, we can show that angle side angle exists. So let me actually try to draw this line one more time a little bit straighter to make sense out of this problem. So let me start over here. Well, okay, we'll leave it at that. Yeah, so we'll leave it at that. Okay, so I'm going to go ahead and say, all right, I know that this segment is congruent to this segment. So this angle, 1, 2, and 3, is congruent to this angle, 2, 3, by alternate interior angle. And that can happen because this line and this line are parallel, and this line that we constructed is our transversal. So if that's the case, this is the tricky part. This is actually the hard part to see. If that's the case, then we know that angle BDC is congruent, BDC is congruent to FCD, to angle FCD. So BDC, yeah, BDC FCD. Okay, so that is by alternate interior angles. So that's true. If that's the case, we now have enough information to prove that this triangle down here is exactly the same as this triangle by side, angle, side. So we have side here, we have an angle here, and we have another side there. So I'm going to write that as my 10th step. So now we have 10th, we have triangle congruency, triangle, in this case BDC is congruent to triangle FCD. So this should be a triangle. There you go. And that is by side, angle, side. Side, angle, side. So if that's true, then we know for a fact that, let me go ahead and grab my red again. This angle, 1, 2, 3, 4, is congruent to this angle, 1, 2, 3, 4, because both of these triangles are congruent, then all parts of congruent triangles must be congruent, or by triangle congruency. So our 11th step is that angle, where are we at? Angle BDC, so this angle BCD is congruent to angle FDC. So we're going to state that angle BCD is congruent to angle BCD is congruent to angle BCD. So yeah, it's congruent to FDC. FDC. And that is by triangle congruency. Okay, And our final step, if that's true, since we showed that these two angles are congruent, then DE has to be parallel to BC by the converse of alternate interior angles. So what we wanted to show, our final step, is that DE is indeed parallel to BC, reason by alternate interior angle converse. And there it is. So again, you guys can pause this at this point and kind of just check things through. All right, guys, I hope this helps. Good luck.